So a quick introduction, I'm Max Piana. Thank you all for joining today. I'm a postdoc research ecologist with the U.S. Forest Service, and I'm based in Amherst, Massachusetts. I studied urban and community forestry at the Yale School of the Environment, where I received my master's and then received my PhD in plant ecology and restoration ecology at Rutgers University, where I was also steward to the Hutchinson Memorial Forest, which is a research forest in old growth natural heritage site. As a postdoc with the Forest Service, I've also co-led the Urban Silviculture Network, which Rich just introduced. And today I'm going to share kind of the outcomes from that workshop and one project in specific that looks at climate adapted oak. So as Rich mentioned, one of the outcomes of this workshop was introducing, well, a discussion around traditional silviculture strategies, forest management strategies for restoring or establishing oak forests. And this typically involves gap creation. This, of course, from our conversations, wasn't a tenable option due to the risk of invasive plants taking over in the vinelands that Rich showed in that last slide there. So the question that we pivoted to was, okay, can we use existing gaps to establish oak and forests in cities? We have a lot of existing gaps within our urban forests, and this is due to multiple factors. Certainly in the Northeast, a lot of our forests in cities are older, the canopy is mature, and there's just natural loss of these older trees. They're susceptible to blowdown. Invasive pests such as emerald ash borer are creating gaps. And so there's all these existing gaps. And so the question is, can we take advantage of these? And what are the methods that we can test and establish evidence-based approaches to establishing oak in that understory? So the main goal coming out of that workshop, besides convening academics and practitioners across the Northeast, was to really develop a knowledge sharing system. And one goal of that as research ecologists was to establish a series of studies that could be replicated across our participating city and municipalities that participated in the network. When we convene this, so we have many studies that have come out of this network effort, but I'm going to share one today that is a unifying study that was involved all members of the network and is replicated across 4 of our partnering cities. And a really critical partner and collaborator in this work is Laura DeWald, who's pictured here to the left. She's a researcher at the University of Kentucky, and she leads the White Oak Genetic and Tree Improvement Program, which is she's conducting a series of progeny studies across the white oak range. And this is an effort to identify traits in white oaks to improve the planting stock that can be distributed. So these could be traits like vertical dominance, so faster growing genotypes that might get over deer browse height faster. But through our conversations with Laura, we also began to think about what might be urban adapted traits. So when we're working within existing gaps, perhaps greater shade tolerance and other traits that could be favorable to urban ecosystem conditions, perhaps higher temperatures or drought tolerance. Given the distribution of our network, as Rich showed, it's extended from Baltimore up to Springfield, Mass. We had this natural north to south latitudinal gradient. And so a kind of obvious question to look at was climate related questions, because we have this warming transect across our participating cities. On the left, you see what is called the Eastern Seed Zone map. I believe I saw Carrie Pike's name join this meeting, and she has helped co-lead the development of these maps. This is a tool that's used by foresters to delineate appropriate zones of moving plant material. So it combines 2 primary data sets. It's the plant hardiness zones as well as ecoregions, and you can see it's delineated by counties. So this is a traditional framework for thinking about how to appropriately move trees and planting material spatially. But of course, with climate change and warming temperatures, the question is whether local plants, in this case oaks, will be adapted to future climates. On the right, you see a map that shows projections for 2080, so 60 years out for urban climates in specific. So this is not just a a climate change projection map. It's thinking about urban climates, considering temperature and rainfall. And what we have here, the line depicted here is from Springfield, Massachusetts, showing 2080, so 60 years out in a high emissions scenario, that the climate in Springfield will be similar to Missouri or just outside of Memphis, Tennessee. So we know that our cities are 2 to 5 degrees warmer, so the pressures of climate change are already being felt in essence within this urban ecosystem, and future changes may be exacerbated. So as we start thinking about traits and climate adapted traits, this brings us to a topic that is common conversation right now within forestry and climate adapted forestry, which is assisted migration as a forestry strategy. And really there's kind of 3 subcategories of this broader topic of moving plants to keep up with climate change, and this question of whether or not they can keep pace. So on the more conservative side, on the left-hand side there, you see assisted population migration. So this is just moving species within their range, so moving perhaps southern provinces more northward. In the middle there, you see assisted range expansion. So it's taking the northern edge of species and advancing that species just beyond that edge. And then to the far right is a more extreme and perhaps controversial approach, which is moving species outside their range and beyond in advance of climate change. So for this study, we're really looking at that assisted population migration study. So working within the native range of 2 plants. We are working with white oaks, Quercus alba, and partnering with the White Oak Tree Improvement Program. You can see that range on the top middle right there is the native range of white oak, and then the projected importance values. So that's how the importance of that tree in future climate scenarios. So you can see it advancing northward. And we're also looking at chestnut oak. Again, our network is located within that native range, although we're closer to the northern edge of chestnut oak. So for this study, we included seed collection from all participating metro regions from the network, from the workshop that Rich presented, as well as southern sourced seed zones. Using that projection map, we collected oak acorns from Kentucky as well as Tennessee. And this occurred in 2021, the fall of 2021, where we collected over 100,000 acorns of both white oak and chestnut oak. All of our partners, our city partners and collaborators were instrumental in this, going out and identifying trees, following protocols that were set up by Laura DeWald and her team for collecting oaks. And these were all shipped to Laura's lab in West Liberty, Kentucky at their State Division Forestry nursery there to be grown up. In February, these were then grown as part of that progeny study, or in their seed banks there. And in February 2023, we had a team of scientists that pictured here is Rich to the right, our grad students, Vince D'Amico from the Forest Service and Tara Trammell from University of Delaware. And we collected these seeds by progeny, by knowing their parentage, and transported more than 20,000 seedlings north to be planted in a series of studies. Now, as Rich mentioned, we're working in existing gaps. You can see on the left here, Rich pictured it near a fallen beach. This is in Baltimore. And we worked to clear these where there was natural snags or fallen trees, to clear out gaps, prepare them for planting, and set up what we call a reciprocal planting or common garden study. So in each of these gaps, which were replicated, 10 of them across each city, so 40 gaps total, we planted half siblings, so acorns collected from the same tree, from all of our seed zones represented in that previous map. In addition to the gap planting, we also replicated the progeny studies that the University of Kentucky and Laura are leading. And these are studies that are located across the white oak range. They are planted out in the open. They're called oak orchards. And this is where we can track traits. So in addition to having the local genotypes and progeny study, we've also expanded this to include seed sources from outside of that local zone. And you can see here, these are located at Silburn Arboretum. the City Arboretum in Baltimore, Lasden Park Arboretum in Westchester County, just outside of New York City, as well as the Springfield Nursery. These were planted with our city partners, as well as volunteer groups and workforce training groups. So as I mentioned, we have these series of studies that are replicated across the Northeast from Baltimore up to Springfield. There's 3 oak orchards total with more than 2,000 white oak seedlings that have been planted. This occurred this past spring. In the oak gaps, we have over 40, we have 40 gaps have been planted with 6,000 trees. And in all of these, it's a common garden study, so we can track climate performance. We're excited to have the study installed. We just collected our first round of survival and growth measurements. We're lucky to have over 95% survival in our canopy gaps. And moving forward, we're preparing to track survival growth, both in terms of diameter and height, as well as the phenology. So bud break, bud burst, looking at potential cues from winter damage, so as well as drought. And then we'll be testing different physiological mechanisms that might be driving either adaptation or maladaptation across these trees. In addition to these tree measurements, we're going to be looking at above and below ground interactions. So pictured here is a caterpillar. We'll be looking at herbivory and whether or not there's a relationship or interaction between seed source and its provenance and herbivory rates, as well as below ground interactions with fungal communities. I finally just wanted to make note that this is one study that occurs across all our other sites, but we have many other studies that are looking at other strategies for establishing oak. A study was just completed in Westchester County in New York City, looking at proactive planting of oak seedlings in both existing gaps as well as imminent gaps. So under, in this case, beech trees that are infected with beech leaf disease and may soon create high light conditions favorable to oak establishment. We also have studies that have engaged community projects in Baltimore at the Still Meadow Peace Park and Forest, so looking at planting strategies that can involve community members, as well as pre-planting and post-planting site treatments of oak in Philadelphia, where we're testing strategies around co-planting or nurse trees, herbicide treatment, and other treatments that might be used by standard kind of municipal forestry practice. With that, I will pass it on to Alex Sherman from Springfield City.